Okay, let's try this inequality question. I think it's pretty interesting because it makes you think. The second part really makes you think. So let's try the first part here, and it says solve for x here, this inequality. So we're going to subtract 4. We'll have minus 12 and minus 3x. We're going to divide by negative 3 both sides to get x all by itself, and we should remember to change the direction of this inequality. Well, what will it look like? Well, there it is. I subtracted 4. I divide by negative 3, and then you end up with, you change the direction of this. Instead of less than, x is greater than 4. And there you go. That's the first one solved. Now the next one's a quadratic. We're going to have to subtract 7x. Then we're going to have to factor it, and we're going to have two values to think about. And there it is. We're going to graph it there. We got x plus 3 times x minus 10. It's got to be x times x to give you x squared. It has to be factors of 30 that somehow combine to give you 7. So it's 10 and 3. But the negative's got to win. So it's minus 10x plus 3x. Now you guys, I get so confused here. I don't know why. But when it's less than 0, it means it's negative. And all you have to do is the critical values are minus 3 and 10. But you have to think that what's the region? What's the region that's going to make it negative? And you can test numbers. You can pick any number you like in between negative 3 and 10, and it'll be negative. Like 9 or 8 or 7 or 6 or 0 or negative 2 or negative 1 or even the fractions in between, it'll be negative. If you pick 11, it won't be true. If you pick minus 4, it won't be true. So this is the solution set. And now we're going to write down, we're going to use these two solution sets to figure out the largest integer that works for both. Well, I like to draw a picture. Here's the picture. There's greater than or equal to 4. See how I made it solid? And there's the set. That's everything in between minus 3 and 10, but not including 10 and minus 3. And that's important. So can we think of some numbers that would satisfy both? Well, the first one that works is 4. 4 works in this set, and therefore is part of this set. Now, we're interested in integer values. So 5 is the next, then 6, then 7. Does 10 work? No, 10 doesn't belong there. So the biggest one should be 9, because 9 works in this set and this set. It satisfies both sets. So the story is 9 is the largest integer that satisfies both sets. Hey, that made me think. I had to think about that. And I like drawing the picture. That's good too, because it helps you think about it.